We start all of the measurements that we're going to be doing today. We're going to be converting a meter to a centimeter. So I have 1 meter right here. How many centimeters would that be? So if I have 1 meter stick, how many centimeters would I have?
100.
Yeah, very good. I would have 100. So we have 1 meter, and that equals 100 centimeters. So this is what you're going to be doing, is we're going to be trying to find the area of our solar bag. So the first thing you're going to do is you're going to unroll your solar bag, and I will assign you different sections of the room to do that. When you unwind your solar bag, you need to measure the length and the width. Now there is a formula you can use once we figure this out to figure out the area. Raise your hand if you know the formula in math to find the area of an object like a rectangle. Right, so we're going to use our length times our width. Now you're only going to have 2 meter sticks. I'm going to show you how to measure it with 4, and then you and your partner need to figure out how you're going to measure it with 2. So the first thing I'm going to do is I'm going to take my first meter stick and I'm going to measure my length first. I have 1 meter, or how many centimeters? You can just shout it. I have 1 meter, how many centimeters?
100.
100. So then I take my second meter stick, 2 meters, or 200 centimeters. Then I would have 3 meters, or 300, and I bring my last one over,
400.
and I'm left with 400. And I have that little part right there. We're going to round it to the nearest whole number. So there we would either have 4 meters, or how many centimeters? 400. Now don't write this on yours. This is just an example of how to do it. Your numbers will be different. So 4 meters, or 400 centimeters. I measure my width, and let's say it's 1 meter long. How many centimeters would that be?
100.
I'd have 100. So then we're going to find the area, and I'm just going to write that right inside. My area equals, raise your hand if you could tell me the area in meters, and then tell me the area in centimeters. Right here. Station 3, you're right here. And in station 1 and station 5, I'm going to put you right outside the door here. Okay? So what you need is you need your sheets where you'll be doing your recordings, and you are to answer questions 1 through 6. To answer 1 through 6, that's actually the questions that we just went over.
What was the last one? 70?
Okay, we have about 2 minutes
we have
left.
670.
We got about 2 minutes left. Let me get one more.
770 because 100 meters, and then you got, it's going to be 700, but then you got the 7. That's going to be long, dude. It's like, that's so long, bro. Whatever, bag, texture of bag, length of bag, 700 centimeters equals 7 meters.
All right, so that's your observation of the deflated solar bag, right?
Okay, so
Okay.
in this section right here, the first thing you're going to need to do is we need to answer our hypothesis. So the question is, will the solar bag fly? And then your answer is going to be, if we fill up the solar bag with air and lay it in the sun, then. And you need to fill that part in. You're going to tell me if you think the bag will fly, if you think it'll stay on the ground, if you think the wind will blow it around. And then for your background knowledge, that's where you're explaining where you came up with your answer for your hypothesis.
I'm moving around really quickly.
Good, right? So you're going to see those molecules flying around. It's going to lift that back. Very good. And your explanation should have the word molecules in it. Alright, that's one of our vocabulary words we have up there. We need to explain something about what's happening to the air molecules inside the bag. So I'll give you about a minute to do that, and then we'll head outside and see if we can get this thing to fly. Alright, and I'm going to come all the way down here, and you run to me. Try not to move it. It makes it hard for me to tie this. All right, right now we are trying to get our solar bag to elevate, and we're using the sun's energy. It's heating up the air molecules. It's a very warm day today, so it's about 90 degrees outside. So that means inside the bag we have to get it to about, what do you think? What's the temperature we got to get this bag to?
Probably to 100.
At least to 100. It's got to be about 10 to 15 degrees above the sun keeps coming in and out right now, so every time the sun goes behind the clouds, we have a dip in our elevation, and that's because we're losing the sun's energy. So we have the sun coming out right now, so hopefully we'll have a little more flight coming up. Now we're going to have the students go to the bag, and they're going to touch it to see if they could feel that absorption from the sun's energy.
It's hot, it's smooth, it's hot, but it's really hot. Yeah.
Bag. The reason the bag is so thin is it helps to transfer the energy quicker, but you see when you have a thin bag,
It rips.
it's going to rip very easily. So that's why over the last 10 minutes we've had our elevation go down, because the air's escaping and the air from the outside is getting in there, which is cooler. And that's causing it to go down.
The air is hot inside. Let me put your fingers in here.
So at 10 minutes, we had 20 meters. So make sure you write in 10 minutes, our elevation was 20 meters. And then someone quickly tell me how many centimeters that was in the air. So if it's 20 meters, how many centimeters is that? How many? 2,000. Very good. Right here is where you can begin to make your graph. So we have our elevation and time, and then we have 0, 5, 10, 15 going across the bottom. And at the top, we need to make a scale to show our elevation. What was the highest in centimeters that it went up?
20. I'm 15.
You're giving me meters, I want centimeters.
2,000.
You want a 2,000. So our scale is going to go from 0 to what?
2,000.
All right, it's going to go from 0 to 2,000. And then just make a line graph. Connect your points.
My hair? Oh, that's why it's so hot on my hair, because it gets to the black in my hair.
Which one do you think heated up the most?
The ones with black.
The one's probably with black. So if we took the temperature inside that bag and compared it to that one, we'd probably have a little difference. We'd have a cooler bag.
Great.